ultimately what we want to do with the matrix inverse is to use it to help us solve a system of equations. So that, with that in mind, when we first started this chunk with inverses, we were looking at solving this ax equals b equation, and we said, well, we can't really divide by a matrix, so what do? What we do instead now is, if we do the inverse, if we apply the inverse matrix to both sides, A inverse, and then AX is equal to A inverse B, right? The A and A inverse would cancel, just be the identity, so then we would end up with the equation X is equal to A inverse B, and we're done. Okay, so we just need to, in order to solve this system, we need to represent it in matrix form, and then use this idea of matrix inverse to finish it off. Okay, but the question is, how do we see this? How do we translate this into that ax plus b, or ax equals b form? Okay, so what we end up doing is translating it as, we pick off all the coefficients like we've normally done. 1, 2, 2, 3. Okay, but then we would multiply this matrix by x and y. Okay, and that's because we, if we were to go the other way and do the matrix multiplication, right, we would do row times column, and that would give us the same equations back. And we would just say that this is equal to negative 1, negative 1, negative 1. Okay, so then all I need to do is find the inverse of this matrix, which I'll call this matrix A, find the inverse of that, and we're good to go. Okay, so I'll start with my standard procedure. Okay, 1, 2, 2, 3, append the 1, 0, 0, 1 matrix. Okay, and so then I do negative 2 row 1 plus row 2, put that into row 2, and I get 1, 2, 0. Let's see, first row stays unchanged. Let's see, negative 2, so negative 2 and add is negative 1. Negative 2 and add is minus 2. And then we end up with, let's see, just 3. Try that again. Let's leave that as a 1. Okay? Alright, so then I'm going to do two things at once. I'm going to take negative 1 row 2 into row 2, and I'm also going to take 2 row 2 and add it to row 1. Okay, and put that in row 1. Alright, so then I end up with identity on the left, and then on the right, second row is just the opposite value, so 2 minus 1, and then now I just take 2 row 2 and add it to row 1, so that'd be negative 4 plus 1 is minus 3, and then negative 2 here, add it to that, so negative 2 there. Okay, and actually that's just a positive. Okay, so then this is our inverse matrix, and we can go forth and then say, so this is A inverse, so then I'm just going to say that xy, which is my matrix X, is equal to A inverse times B, which here this is the same as minus 3, 2, 2, minus 1, and then times negative 1, negative 1, and sure enough, when I do this, I get, let's see, 3 times minus 1, 3 minus 2 is 1, and then negative 2 plus 1 is minus 1. Okay, so there we go, and we can always check our answers to make sure it works, but it does, I'll tell you that. Alright, so that's a nice little way to solve a system instead of using row operations forever and ever, or substitution, elimination. You have this other tool in your toolbox now. Alright, so now here in this next example we're going to set it up the same way. So this is the same as the matrix equation, 9, 7, 5, 4, and then xy is equal to 5, 3. Okay, so now we would go through and find the inverse of the matrix. Okay, but I can tell you this matrix we already saw in a previous video. Okay, I'm just going to say if this is your matrix A, I'm going to say that A inverse, we actually found that earlier to be 4 minus 5 minus 7 and then 9. Okay, so then we would have to go through and find that normally, but we can say in this case that xy is that inverse matrix 4 minus 5 minus 7 and 9 times the solutions, so 5, that's a 5, and then a 3. And when you do this, you can calculate the answers. And when you do that, you get -1 for x and 2 for y. Okay, very nice. All right, moving on. And next, we want to do our final example here, and I kind of want to leave this for you to do. I'm going to write down some bits and pieces, but overall you have to do it. So to begin, you'll have to translate this into the matrix equation. -2, 4, 1, 4 minus 13, 10, 3, -9, 6, and then x, y, z is equal to 0, 24, and 15. And with this, then you need, if you call this matrix A, okay, you need to find A inverse, okay, and we already did this, but you can also show that the inverse is 4, 2, 1 in the first column, -11, -5, oops, -5, -2, and then 53 over 3, 8, and 10 over 3. Okay, so you need to find that. But then with that, you can use that to show that the solutions, and this is work for you to do, x, y, z, is equal to 1, 0, and 2. All right, so just another example for you to do on your own and verify your skills. But overall, the idea with solving a system using this inverse matrix approach is that we need to write out the coefficient matrix, our variable matrix, and then solution matrix, and then apply the inverse to the coefficient matrix to both sides to solve the system.